You probably remember when you go to different beaches, even the sand color can be very different. If you come to a monsoon beach in Kerala, for example, you might find the sand is dark, almost like muddy. Whereas if you go up north towards Goa, the sand is much different. Basically, the sand depends on all the material that is ground up by the runoff, the erosion, and so on, and is getting collected at the shore. It's getting washed back and forth and being ground into fine particles that we call sand. So it may be coarse or fine. We will see again, it depends on the season, the wave energy, and so on. And typically the boulders from the local cliffs and the rivers that run into the coasts, the sand that's produced in the rivers, the mud from the rivers if it's a very rainy region, and so on. But also there are places where biological material like coral reefs or reefs of oysters, clams, and other shellfishes, and so on can also contribute. So material is always moving around on the beach. We will see that it's not the back and forth of the tides and the waves, but there is also a longshore transport along most beaches, especially when it's a nice long beach. And we'll see how those currents get set up and how the material is constantly moving along. Before, when we talked about the waves, we talked about the waves coming in, wavelengths getting shorter, wave height getting higher, and the steepness increasing, h over L increasing greater than 1/7, and the wave breaking, right? Now the same process we are going to think of in terms of the strength of the wave, energy of the waves, okay? Long, low waves are going to have a flow up the beach that is nice and smooth. The water is going to sink into the sand. That's called swash, and then gravity is going to pull the water back, and that's called the backwash. Okay, so if the waves are nice and long and they come in and they soak slowly and they wash back slowly, then they keep bringing in the material and keep building the beach face and the berm. Okay, so that's how a typical summertime beach would look, because in the summertime you have fair weather. Go back to your concepts and think about why summer should have fair weather. Okay, always comes down to the energy transport. In the summer you have more energy coming in to the hemisphere which is having summer. So all the latitudes are getting more energy from the sun than in the winter. So the equatorial to pole temperature gradient is going to be weaker, sometimes by tens of degrees weaker. So you are moving less energy. So everything has less energy. Waves have less energy as well. Okay, that's the kind of simpler way about of thinking about it. Okay, overall energy has to be less because the equator to pole temperature gradient is weaker. Okay, in the winter, on the other hand, you have winter storms and so on, which are part of this equator to pole energy transport. So the energy gradient is stronger because the sun is in the other hemisphere. High latitudes are getting really cold, the poles are getting freezing, so the temperature gradient can increase by tens of degrees compared to the summer. Okay, so when you have very high energy in the waves, a wave washes up, brings the swash and breaks on the beach, and before the backwash has had time to go out, the next wave can come and crash on top, and then the backwash can get bigger because it gets soaked with waves coming in, and then the next backwash may not even soak in, it might just wash out the sand. So we will see that the nice beach face that gets built up, low gradient, smooth beach face that gets built up during the low energy of the waves in the summer tends to get washed out, and the slope increases and the beach becomes stripped of the sand in many of the beaches. Okay, so we'll see an example of that with a nice picture. Sand movement along. So the swash and the backwash is the uh, water movement, and the sand movement up the beach face and back out. So it's the gravity driven downflow. Whereas these waves we will see don't come exactly the waveforms are not exactly parallel to the beach face. They will try to become parallel. Why? Again, remember your concept. By the time the wave comes to the beach, it's a shallow water wave, so square root GD is the wave speed. D, the depth of the water column decreases, so the front moves slower than the back, so you waves are trying to become parallel, but they don't quite become parallel. This ends up creating a pressure gradient and an along-shore current. So I'll come to that in the next podcast just to keep this short enough, 5 minutes. So summer, winter, wave energy is different, so the beach face is very different by season. When you get away from the tropics, the seasonality is fairly weak, except you may have a very strong rainy season like in parts of Indonesia, South America, India, and so on. And rain can produce lots of mud and a very different feel to the beach.